1311, April 9th, 2026, right now marks 2,337 hours of progress on the global heart simulation. Currently, a new method has been found for calculating ray intersections with voxels that should allow for a more efficient line of sight algorithm. As in some of the previous methods, a ray was calculated for every single voxel, and then those arrays were subdivided into nodes, and then the nodes were merged. But what the new method instead does is create less arrays in the first place. So instead of calculating an array for every single voxel, what the new method does is only calculate rays toward the voxels along the exterior of the grid, and then it sort of steps along that ray and calculates points, each a voxel's distance away from each other. And what that is able to do is basically grab every single voxel that is within the grid by calculating points along the path to the voxels along the furthest most faces of the grid. And so the intention for the next going forward, now that this has been implemented, which greatly reduces the amount of rays, and as an example, there are currently 1,000 voxels, but only 424 rays are created, and then increasing that to around 125,000 voxels, only 12,000 rays are created. So that does seem to scale very well, but what isn't currently scaling is the nodes, or the points within the grid, as basically what occurs is that for every single ray, a point is created along every single voxel, and the solution to reduce the number of nodes would be to look at how they're created, and some solutions have been created in some of the previous iterations of this. And basically the issue is that for a given ray such as the first point, since there are 1,000 voxels, 1,000, every ray shoots towards the vantage point, so that guarantees at least 1,000 points at the origin of the line of sight. And so what needs to be done is sort of merge them, starting from there and going outward, and that would basically allow for them to be merged along the path to specific voxels in order to make the amount of calculations smaller, which would make the algorithm faster and more precise, which is the intention going forward, is to allow the algorithm to be as not only fast but also as accurate as possible.